This video is intended to be a review of converting numbers from standard form to scientific notation. Let's take a look at our first example, 43,200,000. Now, if you remember our discussion about scientific notation, we stated that there can only be one digit in front of the decimal in our decimal term. If we look at this number 43,200,000, we obviously have more than one digit in front of the decimal. How do I know this? Well, it's a good question. At the moment, we can't see a decimal in there, do we? That's because if a decimal is not visible, we know that the decimal is actually at the very end of the number, all the way to the right. Now, to create a decimal value, or a decimal number, a decimal term, that has one and only one digit in front of the decimal, we are going to go to the very left of the number. And we're going to search out our first non-zero number. In this case, that happens to be a 4. We are going to put a decimal immediately after that, and rewrite the rest of the number as it was. Now, I'm including the original decimal because we will be using it in a moment. Our task at this point is to try and determine the exponent that we'll be raising our base 10 to. To do that, we're going to count the number of decimal places that we move from the new decimal place all the way back to the original. In this case, it's once, twice, 3 times, 4 times, 5 times, 6 times, and 7 times. Now, to determine the sign on that exponent, we think about which direction we moved. Since this was in the right direction, we think of our number line. On the number line, numbers to the right are positive. Therefore, our exponent is a positive. Also, since this number happens to end in a bunch of zeros, we can actually cut these zeros off, since nothing after the zeros is going to be useful in our decimal. Therefore, our scientific notation is 4.32, or 4 times 10 to the 7th. As always, circle your answer to complete the problem. Let's try another one. We now have the value of 76,090. Let's first identify where the original decimal is. Since there's none visible, we know it's all the way at the end to the right. Move to the left of your value here, and start looking for your first number that is not a 0. In this case, it's a 7. Drop the decimal after it, and rewrite the rest as it was. I am including the original decimal as well once again to help us. Now, let's go ahead and figure out what our exponent should be. We moved once, twice, 3 times, 4 times in the positive direction. So our exponent is a positive 4. Once again, we can look at our decimal term, and we recognize that there's a 0 at the end that is not a significant figure or a significant digit, and therefore we are not going to use it. So our answer, 7.609 times 10 to the 4th. Both of these examples had a positive exponent. Let's take a look at some examples that'll have negative exponents. Once again, we're going to start by identifying the original location of our decimal. In this case, it's visible right here. Now, let's look for our first non-zero number as we travel from the left to the right. In this case, it's a 2. So now we have 2, we drop the decimal after it, and everything after that is written as normal. The original decimal was way back in front of it. So if we go ahead and count From the new decimal location to the old decimal location, we are traveling once, twice, 3 times, 4 times, 5 times. But this time we're moving to the left. If we think about our number line once again, the numbers on the left of the number line are negatives. Therefore, our exponent in this case is a negative. Let's take a look at the next example. The same idea applies. Locate your original decimal. Go ahead and find your first number that is not a 0 as you travel from the left of the number to the right. In this case, it's a 1, so we put a decimal after it. As always, since we're in scientific notation, we have a times 10. And now we attempt to find our exponent. Count from the new location of our decimal to the original. We count that we moved 3 locations, and we move to the left. Therefore, we are looking at an exponent of -3.